Okay, so in this unit or in this course, we cover two types of triangle. We cover the right angle triangle, when we try to solve the right angle triangle. And the other type of triangle that we look at is the oblique triangle. So oblique triangle is a triangle that does not have a 90 degree. Okay, so these are the two types of triangle that we're going to look at, either oblique triangles, no 90 degree, or the right angle triangles. We're going to start with the right angle triangles first. So right angle triangle have an angle of 90 degrees. Right? And then for the three sides, there's one side that it's not going to change. We're not going to change its name. It's going to have the same name all the time. And that's a side that's across from the 90 degree. Okay? So the side that's across from the 90 degree, what do we call that? Does anyone know? Hypotenuse. Hypotenuse is the name of the side that's always across from your 90 degree. No matter how you draw your triangle, so let's say if your 90 degree is right here, right? Your hypotenuse is going to be right across from the 90 degree. No matter how you draw it, the location of the hypotenuse is going to be across from the 90. For the other two sides, they change their names according to the angle that is given or the angle that you're interested in. Okay? So for example, I'm going to look at the same triangle here. And let's say the angle that is given to me, or the angle I'm interested in, angle right here, I'm going to call it angle A. So I gave you angle A, or I'm asking you to look for angle A. Then according to angle A, where is your opposite side to angle A? BC is your opposite side to angle A, right? So BC is opposite to angle A. We call that the opposite side. Okay? And that leaves me with side BA that is not named. We call that side the adjacent side. Okay? So there's three names. Hypotenuse doesn't change the location, but the opposite and the adjacent changes according to the given angle. Okay? So if I have that same triangle, but I told you that you know angle C. So I gave you angle C. So this is the one that's known. We're going to have to name the triangle according to angle C. Where's your hypotenuse? CA or AC? AC or CA, right? It doesn't matter which way you go. This is going to be your hypotenuse. It's not going to change because that's the one across from the 90 degree. Okay? Remember, the angle C is my given angle, or what we call the angle of focus or angle of interest. According to angle C, where is your opposite? BA. And according to angle C, then CA is your, or CB is your adjacent. Okay? So you see that if you're looking at these two triangles, they're exactly the same triangle, but what I changed here is the given angle, okay, or the angle of interest. Because my angle of interest was A in the first one, my opposite is CA, CB, and my adjacent is AB. While because I gave you angle C in the second example, the opposite and the adjacent changed location spots. Does that make sense? Naming the triangle is half of the battle. Okay? Understanding how to name your triangle properly can help you solve the triangle properly. Can help you choose the correct formula and find the correct answer. Does that make sense to you? Okay. Now, why do I need to name them this way? Because there's three formulas technically there's 4, but 3 that uses the opposite adjacent hypotenuse to solve a right angle triangle. We call them the primary trigonometric ratio. Have you guys heard of the primary trig ratios before? Or trig ratios? How about SOHCAHTOA? Have you heard of SOHCAHTOA before? So these are your primary trig ratios. Okay? The name for them, they're called primary trig ratios, and the acronym for it is SOHCAHTOA. SOHCAHTOA are the ratios that we use to solve for the triangle. On your calculator, do you see do you guys have calculators? That's one thing that you need in MAP4C is a calculator. Don't tell me that you're using your phone because that's not the correct calculator. Okay? Make sure you get a calculator and make sure you get a good one. Don't go to the dollar store and buy one, please, because they don't work properly. Okay? They work backward, and it's going to be, the formulas that we use are a bit complicated, right? And you want them to be as straightforward as possible instead of a backward calculator. Okay? All right, so on your calculator, can you locate sine, cosine, and tan? Can you see the buttons? SIN, COS, TAN. Do you see them? If you don't have one, can you share with the person sitting next to you right now? Okay, these are your primary ratios, sine, cosine, and tan. We use them. Do you guys see them? So we use these sine, cosine, and tan in right angle triangles. So, do you guys know what SO stands for? So, what does SO stand for? Sine. So sine of the angle, I'm just going to call it angle A, is opposite over hypotenuse. So where the SO comes from sine stands for S, opposite hypotenuse. Okay? That's why we say SO. Okay? How about CA? So cosine angle A is adjacent over hypotenuse. Remember the first thing we did? We named our triangle, right? We named our triangle because we need to be able to locate them. We need to be able to locate the sides so we can use these formulas. Can you guys, do you mind squeezing in a little bit so we can fit more people on the tables? Thank you. You guys. So again, CA is cosine adjacent hypotenuse. Okay? And then TOA, so that's your tan A, opposite over adjacent. And that again that's where TOA comes from. Okay? So we use these three formulas with a right angle triangle only. Okay? We'll talk more about these formulas. We'll talk about more about examples when we get to our unit. But remember these three formulas, we use them only with right angle triangles. Now there's another formula that we use with right angle triangles to solve for sides. What is it? Pythagorean theorem. many of you heard of Pythagorean theorem? Good. Pythagorean theorem can only be used with right angle triangles. And Pythagorean says that if I call my sides A, B, and then the hypotenuse is called C, if I add the square of the two legs, it's going to equal to the square of the hypotenuse. So that means if I have A squared, so the square of the two legs, so A and B, if I add them, it's going to equal to the square of the hypotenuse. Okay? This is the Pythagorean theorem, and we use that whenever I have two sides in a right angle triangle and I'm looking for the third. Okay? Now, if I have side A and side B, I can just plug them in the formula, and I can solve for C, right? So let's say if A is 3 and B is 4, okay? And I'm asking to solve for side C. It's simple as 3 squared plus 4 squared equal to C squared. So that's 9 plus 16 equals C squared. So that's 25 equals C squared. So C equals 5. We can't stop right here because I'm asking you for side C. So your last step is to square root both sides, and that will tell you that C equals 5. Right? So you see that I've used my formula, plugged in the values to solve for side C. Does that make sense to everyone? Now the question is, what if I have B and C and I'm looking for A? Can I still use this formula?
Yes.
Yes, but what do I have to do to it?
Move 0 back to C, so it becomes A squared equal to C squared minus B squared.
That's right. So I have to isolate for A. Okay? So in the case that I know, if I know C and B and I'm looking for A, so I'm looking for A, what I have to do is I have to move the B squared over to the other side because I want to solve for A, and that would be C squared minus B squared. What if I know A and C and I'm looking for B? So B squared equals C squared minus A squared. Because in this case, I'm looking for B, so I'm moving A squared over. Okay? Remember, at the end, you always have to square root so you can find your answer of the side length. What is known about the hypotenuse? What's special about the hypotenuse? Other than it's across from the 90 degree.
That's the longest side.
It is the longest side of the triangle. Okay? So if when you're finding your answer, you find that your B or your A is longer than C, that means you've done something wrong. Go back and check your work. Okay? So C or your hypotenuse is always your longest side. that I want to go over in this review is the angles inside of a triangle. What's the sum of all three angles inside of any triangle? 180, right? So inside of any triangle, if I add all three angles, right? That's going to equal to 180 degrees. This is a useful information because if you know two of the angles, you can find a third, right? If I told you that this is 60 and 40, then you know that C is 80 because 60 and 40 gives 100, 180 minus 100 gives you 80. Are we okay with this so far? I'll get back to this page, 1 second.